As we continue with the elimination method for solving a system of equations, we looked at ways we could add the equations or combine the equations together to get one of the two variables to drop out. But that was, the problems we worked with yesterday all had a variable that would already drop out. If we tried to add the two equations together as they are currently, we wouldn't get either the s's or the t's to zero out. We would just get 14s plus 4t, and that does us no good. So what we have to do is we have to modify one of the two equations so that we have opposite signs but the same number as the coefficient on that variable. And that would be real easy to do with the t variables in these two problems. If we multiplied everything in the top equation by -1, okay? We multiply everything by -1. We would get -5s minus 2t equals -6. We just basically change the sign of everything in that equation. We're going to leave the second equation alone. 9s plus 2t equals 22. And then we're going to add the two equations together. Now the t's will zero out. I'll be left with 4s plus 0 equals 14, or 16. 4s is equal to 16. Divide by 4. S would be equal to 4. So now that I know that s is 4, I can plug it back into either one of the two equations. I'll use the 5s plus 2t equals 6. And put 5 times 4, that's what I found for s, plus 2t equals 6. That would be 20 plus 2t equals 6. Subtract 20 from both sides. I get 2t equal to negative, minus 20, negative 14. Divide by 2. T is -7. So I had to do a little bit of modification before I could use elimination. Here in example 2, the same thing will apply. As we have it, as it's written, nothing will zero out. So I need to modify one of the two equations. Okay. I'll go ahead and multiply the top equation by -1. And that'll give me, basically all it does is change the signs. It'll give me a -12n plus m equals a +14. I'm not going to mess with the second equation. It stays as 6n minus m equals -8. Now I can add the two equations together. The m's will zero out. I'm left with -6n equal to 6. And so I'm going to divide by -6 on both sides. N would be -1. Take that again and plug it back into one of the two equations. 6 times -1. I'm using the second equation. 6 times -1 minus m equals -8. That'd be -6 minus m equals -8. Add 6 to both sides. -m is zeroed out. -m is equal to -2. So divide by -1. M is equal to +2. There we go. There's n and there's m. All right, example 3, it's not going to be so easy that I just have to multiply by -1. I have a 2x and a 3x. Those are kind of close. I can't really get the x's to cancel out without messing with both of them. But on the y's, I can multiply the top equation by -2, and that'll give me a -2y, and so the y's will zero out. So that's what I'm going to do. I'm going to multiply every term in the top equation by -2. That'll give it -4x minus 2y equals -46. So hopefully we can see what I did. I took the top equation and I multiplied every single term by -2. So everything got doubled and it changed to its opposite sign. The second equation, I am not going to modify at all. I'm going to write it just like it is. 3x plus 2y equals 37. And hopefully you can see that now when I add the two equations together, the y terms will zero out. I'll be left with -x equals a -9. So that means positive x is +9. Take that, again, plug it back into the equation. I'm going to use the first equation. 2 times 9 plus y equals 23. That'd be 18 plus y is 23. Subtract 18, and y is 5. So y is 5, and x is 9. Here in example 4, it gets even more complicated, not more complicated, but requires more work to get one of the variables to drop out. I need, in either the x column or the y column, I need the same number with opposite signs. In the x column, the least common multiple of 4 and 3 is 12. Okay? In the y column, at least I have opposite signs that gives me a little bit of a step ahead on trying to get the equations to, get the variables to drop out. So it doesn't really matter. It's going to be about the same amount of work either way. I'm going to go ahead and go with trying to get the y's to cancel out. So what I want to get is, I have a 3y and a -5y. I want that to become 3 and 5. The least common multiple of 3 and 5 is 15. So I want that to become 15y, and the bottom one to become -15y. So that's going to be plus 15y and minus 15y. And that will get me, that will allow me to eliminate the y variables. Now, let's go back and figure out what I had to do to get that to happen. Well, the top equation had to be multiplied by 5. To make the 3y become a 15y, it had to be multiplied by 5. So everything's going to have to be multiplied by 5. So that'll be a 20x. Let's go ahead and put that in red again. 20x plus 15y equals 8 times 5 is 40. That's not a 40. Okay. Looking at the second equation, this had to become, this -5y had to become a -15y, which means I had to multiply it by a +3. So I'm going to have to multiply everything by a +3. So that'll become 9x minus 15y equals a -669. Now when I add them together, I get my y values to drop out. I get 29x equals negative 29. So that means that x was negative 1. That makes at least the second step a little bit easier. Plug negative 1 back into either one of these two equations. Doesn't matter. We'll go with the top equation. 4 times negative 1 plus 3y equals 8. That becomes negative 4 plus 3y equals 8. Add 4 to both sides. We get 3y equals 12. Divide by 3. Y is 4. There we go. There's the solution to the system of those two equations using elimination. Negative 1, 4.